Composition of compounds. Chemical formula gives us information about the numbers of atoms of each element in a compound. If we combine that with the molar masses, that can give us relative quantities of the elements in terms of mass. So the mass percent composition, or the mass percent of an element, is the element's percentage of the compound's total mass. So this is a general statement of what percent means. And if you can remember this, you can actually just kind of figure out a lot of percent problems. Percent is equal to the part that we're interested in divided by the whole thing times 100. So a mass percent, we're looking at the mass of the element divided by the mass of the whole sample times 100.
So if it's asking you for one specific thing, that's what you would put on the top, divided by the mass of the entire thing.
So, like here's the formula written out for mass percent of element X. So it's the mass of element X divided by the mass of the whole compound. Well, this is one of those intensive properties that doesn't depend on the amount of stuff. The percent of element X is the same whether you have a little bit of the compound or a lot of the compound. And so a lot of times these problems will show up and they don't give you the mass of the compound. And so you kind of have to just like, what do I do? We can choose the size. And so it's easy to choose 1 mole. And so from the formula, we can use, we can figure out the mass of element X in 1 mole. And then we can find the mass of 1 mole of the whole compound. That's going to be the molar mass.
And when it says mass of 1 mole of compound, it would be whatever number is in the equation by that number?
Yeah, it would be just finding the molar mass, like we just learned how to do. So we can find percent composition from a formula. We can also find it by analyzing the different elements. And we'll be doing that in one of our labs. So you can take an existing compound, break it into its elements, find their masses, and calculate the composition that way.
Can you do a quick example of this?
Yes, I can. How about this one? Acetic acid is the active ingredient in vinegar, and here we're given the formula. Calculate the mass percent composition of oxygen in acetic acid. So, the mass percent oxygen is going to equal the grams of oxygen divided by the grams of the compound times 100. There are no numbers in the problem. So this is where we choose. We're going to choose to do our calculations for 1 mole. I can figure out the mass of 1 mole of acetic acid. I'm just going to use the procedure for finding the molar mass. So 2 times the mass of carbon plus 4 times the mass of hydrogen, and 2 times the mass of oxygen. I'm coming up with 60.052. So 1 mole of acetic acid weighs 60.052 grams. So that goes in the denominator. What is the mass of oxygen in 1 mole of this compound?
32.
It's 32. So I wrote out my work here. This is the oxygen. That is the mass of the oxygen in the compound. There's that many grams of oxygen and this many grams of the compound. There's 2 moles of oxygen in 1 mole of the compound. That's why it's 2 times 16. So 32.00 grams up here We're going to multiply by 100 to make it a percentage. 32 divided by 60.052 times 100. I'm going to round my answer to 4 sig figs. 53.29%. So by mass, oxygen is 53.29% of acetic acid. Yeah, that's a lot. Any questions?
Why did you do 4 sig figs?
I did 4 sig figs because I used masses with 4 sig figs,
Okay.
right? And so that limited this. If you use more sig figs in your masses, from a different periodic table, you could end up with more sig figs in your percentage. Any other questions? Mass percent works very nicely as a conversion factor between mass of element and mass of compound. Here we need to remember that percent literally means per 100. So if we look at Freon 112, here's its chemical formula. And we're being told it's 69.58% chlorine by mass. That means there are 69.58 grams of chlorine per 100 grams of compound. You can do that with any percentage. There was a problem in the homework that drove a lot of you batty, involving an ore called galena, a mineral called galena, and an ore and some lead, and they're trying to make a sphere with a certain mass, and they want to know how much ore you need. And there were a bunch of percentages. All of those percentages can be written as this many per 100 and used as conversion factors.
What homework?
Mastering chemistry,
I just felt that question.
the chapter 1 homework, mastering chemistry. I think it was the last one.
Can you work that problem?
I can, but I'm not going to do it during lecture. Let's do this example. What mass in grams of iron 3 oxide contains 58.7 grams of iron? Iron 3 oxide is 69.94% iron by mass. Well, let's write down the numbers. 58.7 grams of iron. Iron is Fe. And then we're told 69.94% iron. That means 69.94 grams of iron per 100 grams of iron 3 oxide. I'm going to write the formula because it's faster than writing out the name. It's Fe2O3. So those are the numbers from the problem. And what do they want me to find? The mass of the iron 3 oxide. So the Fe2O3. So I've got these two things that they gave me. I want to start with this one. This is just a single unit. This looks like a conversion factor. Grams of this thing over grams of that thing. I can use this to convert directly from grams of iron to grams of iron oxide. So 58.7 grams of iron. And we're getting to that point in the class where just writing grams isn't good enough. Grams of what? Because here we've got grams of iron and grams of iron oxide. I want grams of iron oxide on top, and I want grams of iron on the bottom. And I'm doing it that way so that the units work out. I don't have to remember, am I multiplying or dividing or what am I doing? I'm just putting the units in, and they're telling me what to do. Then I look at this relationship, and I see that the 69.94 is with the iron, and so I need to write that with iron on the bottom, and the 100 grams is on the top with the oxide. Some problems it'll be the other way around. Just obey the units. So now we have 58.7. Helps to turn on the calculator. Times 100 divided by 69.94. How many significant figures should this result have? 3. 83.9 grams of iron oxide. This percentage has 4 sig figs. When I write that many grams per 100 grams, I am intending this 100 to be an exact number because that's part of the definition of what percent is. Any questions? There are other ways to think about solving this problem and come up with the same correct answer. Some of you are really good with working with percentages. So, if you have a different method, that's fine. But if percentages are confusing, try it this way. So percent composition is a useful conversion factor. We can also get conversion factors from the chemical formula itself. This ends up being a little more tedious, but it still gets the job done. So the formulas give us the relationship between numbers of atoms and numbers of molecules, or moles of atoms and moles of molecules. So this formula for that Freon tells us there are 2 moles of carbon in 1 mole of the compound, or 4 moles of chlorine in 1 mole of the compound. Or how many moles, did I say chlorine or fluorine? Oh, I can't even understand what you guys just said. 4 moles of chlorine to 1 mole of compound. How many moles of fluorine? 2. It's just from the formula. 2 moles of fluorine in every 1 mole. And so those relationships are very useful. Important to remember, this is amounts in moles, not masses in grams.
So you just convert to grams.
So we're going to have to convert to grams. We can't say there's 4 grams of chlorine in 1 gram of this. Right? That right there should not make sense. I saw another great t-shirt. 4 out of 3 people have trouble with math. You can't have 4 grams in 1 gram of anything. It's just not possible. Let's do an example. Determine the mass of oxygen in a 7.2 gram sample of aluminum sulfate. So we write the number down. 7.2 grams of aluminum sulfate. Okay, aluminum sulfate, what's that? Yeah, you're like, I gotta think about this one. So mentally, we're doing Al3 plus SO4 2 minus. Got to get the charges right. So this is going to be Al2 SO4 3. 7.2 grams of that, and we want what? Mass of oxygen. Grams of O. Can I go directly from grams of compound to grams of element? Not with the information I'm given. If they gave me a percent composition, percent oxygen, I could do it. I could calculate the percent composition of oxygen, but that would take just as long as doing it the way we're going to do it. What I have from the formula is the relationship between moles of compound and moles of oxygen. 1 mole of Al2 SO4 3 has how many moles of oxygen? 12. Because I have 3 of these packages. Each package has 4 oxygens in it. 3 times 4 is 12. This will get me moles of this to moles of that, but I've got grams and grams. So I'm going to have to use molar masses as well. And I'm going to go from grams of aluminum sulfate to moles of aluminum sulfate. And yes, it gets tedious, writing the formula over and over again. And then we're going to go to moles of oxygen and then grams of oxygen. I'm going to try to write small so I can get this all on one line. 7.2 grams of Al2 SO4 3. 3 arrows, 3 conversion factors. Next is moles of Al2 SO4 3. Next is moles of oxygen, and then grams of oxygen. You come up with the path, you put the units in. Got moles of oxygen down here, got moles, Al2, SO4, 3. I should really change this to a less tedious example. So moles cancel, grams cancel. This middle term, moles to moles, is the easy one. It just comes from the formula. I've got 1 mole of the compound and 12 moles of oxygen. How many grams of oxygen per mole of oxygen? 15.9994. How many grams of aluminum sulfate? You gotta calculate that. Okay, 2 times 26.9815. How many sulfurs? 3. 3 times 32.07. Oh, no, 66. And 12 oxygens. 15.9994. Okay, so there I